Hey guys, welcome to day 83 of Codeforces Every Day Until GM. So if y'all watched last video, y'all know I had no audio that entire video. A little bit embarrassing, but 110 of y'all watched it, so like what is that about? Like do I just yap too much in my videos or what? Like the actual solutions to the problems I did in this video are on my channel too. It's Rudolph and Christmas Tree, Romantic Glasses. They're both problem of the day problems from the Codeforces Discord server that y'all can join in the link in the description. We talk about all sorts of stuff. It's actually pretty active, surprisingly. We only have 9 people so far, but like half of us have been chatting it up today, so it's pretty fun. Join if y'all want to. But yeah. Okay, today let's do some problems. Let's do a 1200. Let's do this one. And then let's do like a 1400 later. I am trying to bump up the difficulty of the problems I solve. All right. Turtle tenacity, continual mods. Given an array, determine whether it's possible to rearrange its elements into b1, b2, all the way to bn, such that b1 mod b2 mod blah 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 equals 0. Here, x mod y denotes the remainder from dividing x by y. Also, the modulo operations are calculated from left to right. That is x mod y mod z. Okay, yeah, that makes sense. For example, yeah. Okay. So let's take in our input, t equals int input. Then we'll have for underscore in range t, n equals int input, a equals list map int input split. Okay, so what do we need to do? We are given a list and we want to rearrange it such that the mod of the first, like if we mod each element in the array starting with the first, it does not equal to 0. Okay. I'm starting to think of some like prime numbers or something, right? Or like multiples. If we like can get to 0, then that's no good. Or like, can we do something with smallest to greatest? Because like 5 mod 7 is still 5, right? The number won't change. And then, let's just look at the test cases. 1, 2, 3, 4, 5, 6. So this is obviously possible because 1 mod 2 is 1. 1 mod 3, 1 mod 4, 1 mod 5, 1 mod 6. Yes, that's what I was talking about earlier. Like, it'll always be 1. But then in this case, it's impossible because 3 mod 3 is 0. And then in this case, it's possible because 3 mod 2 is 1, 2, then, wait, and then 1 mod 2 is 1. But can we do the pattern of 2 mod 2 is 0, and then 0 mod 3? If we do smallest to least, what happens? 6 mod 5 is 1. 1 mod 4. So, okay, so if we can get 1, that's very good, because 1 mod anything is 1. Right? And the only way to get rid of the 1, to get like a 0, is to have another 1. So as long as we can produce a 1, it's possible, unless there's multiple 1s. Right? Can we have multiple? Yes, we can. So this one here, test case 4, is a no, right? Yeah, that's correct. Test case 6, 1, 2, 3, 4, 5, 6 is also a no. So this is very interesting here. I think this kind of helps confirm, but it doesn't confirm for sure. It just helps confirm the theory that if we have two ones, it's kind of impossible. Is there any way to disprove that? Like, I think this is true. So if a dot count 1 is greater than 1, print no. Continue. All right. Now what? It's not just that, because if they have duplicates, like this one, it's a no. But then you have stuff like this where it's a yes. Then you have a mix like this where it's also a yes. And then you have something like this, which is a no, because they're all the same multiples. I feel like there's some simple answer to this. Like, I should check sorted and then reverse sorted and see if any of those work. But I feel like it's probably more complicated than that. But we should check this. And clearly sorted does work, because we're going to have a 1. Like, if we have a 1 and then the rest, there's no more 1s, it's just possible. But if we don't have a 1 at all, then sorted doesn't work for this one, right? Because 2 of the same. But reverse, 3 mod 2 is 1. Then 1 mod 2 is 1. So this actually works. This works reverse too. This just doesn't work no matter what. And then it's no, yes, no, yes, no. So yes, no, yes, no. This just doesn't work no matter what, because there's two 1s. Then this one is a yes. Reversed, so 2 mod 2 is 0. 0 mod 1 is 0. So reverse doesn't work for this. But this is a yes, because there is 1 1. If there's 1 1, we just put it in the front. So, okay. So we just check if there's a 1. Well, there could be cases of where like 2 4 4 or something, right? 2 mod 4 is 2. Okay, it's not just 1, right? It's like 2 4 4 could follow the same pattern of as 1 2 2. All right. So this case is important. And then this case, 1 1 2 is a no, because we have two 1s. So, okay, so I don't think this is a hard limit. I think what matters is the count of the smallest. No. It's a GCD thing. I feel like this isn't a hard thing anymore. It's like, GCD. Can I GCD a list in Python? Yes, I can. Does that help me at all? 244 GCD is 2. 244 is possible. We just check if there's multiple 2's. Right, but then 224 is impossible. Okay. Okay, I think this is it. I think GCD equals math. CDA if a.count GCD is greater than 2, print no. Continue. Alright. Now, so this GCD is all 3, right? Okay, let's just print out the GCD before we do anything. Do we need to unpack this? Okay, yeah, 1. Alright. Okay. No. GCD is 3, so this is yes. GCD is 1, so this is no. GCD is 1, this is yes. This is no. This is GCD is 1. So this one's yes. GCD is 3, so this one's no. So is it as simple as I believe this will pass for these example cases? No, it doesn't. Why? What's this? Okay. So let's try to yes. Right, because do 2, 4, which is equal to 2, then 2, 4 again, which is equal to 2. What about something like this case is tripping me off. So 1. 10, 10, 10. We can do 5, 10, which is 5, then 5, 10, then 5, 10 again. So duplicates don't matter. And then we can do 5, 2, 5, which is 1. What if it was 4? If we did 4, we can do 4, 10, 4, 10. Well, we can do 2, 4, which is 2. Now let's try this. 6, 4, 2, 10, 10, 10, 2. Should be, it's no. Why? Is it actually no? Let's see. GCD, or okay, if we did 2, 4, we could, 2, 2, we had 10, 2, we get 0, so we can't do 10, 2. 10, 4 is 2. We could do 4, 2 is 2. Yeah, this is impossible. I think this is right. Low key, I wish I had a better way to prove it. I don't really know how to prove it. But like, this is what my intuition is telling me. Because duplicates don't really matter in this problem. Unless it's a duplicate of the GCD. Simply because of the case where, like, if you have a number less than and a number greater, like this 510 case, for example. 5 mod 10 is just 5, and then you can spam that for all the 10s to get rid of all of the duplicates. But if you have two of the same GCDs, then even if you spam everything and it works perfectly fine, you'll end up with GCD mod GCD, which is just 0. But is there a case where you can like just spam everything and then not have the GCD anymore? If the GCD is going to be smaller, then yeah, no, this is correct, I think. Let's submit it and find out. Okay, yeah, we were 100% there. It only took 17 minutes to solve a 1200. That is probably one of my fastest 1200s. I was low-key there, like even faster, but I wasn't, like, I was just double checking, right? Let's take a look at the proof. What's this called? Turtle tenacity. Sort the array in non-decreasing order. I didn't do that. If A does not equal, if A1 does not equal to A2, minimum is unique. Therefore, place A1 at the front, and the result after is just, the answer is yes. If it, then there's some element. Okay, so they're saying this, if the smallest is unique, then we can just build A1 and then anything else. That's correct, we got there. And then if the two smallest are equal, then a possible solution is rearranging the array AX, A1, A2, and then everything else. Multiples of the minimum. Okay. I think my solution was much easier to understand, I'm not gonna lie. Yeah, mine was way better. I don't know what they were waffling about. Okay. That was good. That was the fastest I've ever done a 1200, I think. Let's do a 1400. I'm feeling it today. Oh, what? My internet. No, it's definitely up. Oh, okay, there we go. Hello 2024. Data structures in DP. I had a whole conversation about DP. Was it yesterday? Days are kind of blurring. But yeah, had a whole conversation about it in the Discord. Check it out if y'all are interested. You're given an array A of size n. You will do the following processes to calculate your penalty. Split the array A into two possibly empty subsequences S and T such that every element of A is either in S or T. Okay. For an array B of size m, define the penalty PB of an array B as the number of indices I between 1 and n minus 1, where BI is less than BI plus 1. The total penalty you will receive is PS plus PT. If you perform the thing optimally, find the minimum possible penalty you will receive. Each test contains multiple cases. The first line contains a single integer t, t, n, and a. So it's the same input as last problem. Let's remove this import. Okay. So, given an array, split the array into two subsequences such that every element, okay. So just split it into two, but we have to split it with all the elements present, right? For an array B of size m, penalty is the number of indices between 1 and m minus 1. So it's just the length where the bi, so where the current element is smaller than the next element. So the total penalty we will receive is the sum of both. Okay, I understand. So we split the array, check the penalties, we want to find the smallest penalty. So there's like some optimal split, right? Yeah, that's what we're looking for, the optimal split. So in the first test case, a possible way to split 2, 4, 5 subsequence. All right, I see. So you can totally split it like this: 1, 3, 2, 4, 5. The penalty is 2 plus 1. Okay, I see. Eight, 3, 1. 2, 1, 7, 4, 3. Okay, I see. So you basically want to So if numbers are in decreasing order, you want to keep them together. Like 7, 4, 3. You want to keep those together. Numbers are in increasing order here. So what do we want to do? I don't really know how to take care of increasing order yet, but decreasing. So this is decreasing. This is decreasing. Decreasing are the same, right? We can keep these together, and then so I see three groups here. This, and this. Okay. How do we know where to split? Because if we do 8, 3, 1, 1, we don't lose anything. We can also do 8, 7, 4, 3, then 2, 3, 1, 1, and still only lose 1. Right, so 8, 2, 3, 1, 1, 7, 4, 3. If we pick if we sort by longest, do 3, 1, 1. Huh. This is definitely the most important case here, right? This is just 3, 3, 3, 3, 3, 0. This is just 1, 0s. 2, 1. This is just 2, 1. Both 0. Okay. So our focus is these two cases. I think what we want to do okay, so this question looks something like this to me right now. Where's my ink sync test? 823111743. I see this as splitting it here and then here. Now we check this case is not very good. Because it's like I can't really test my theory that well. Like you immediately find the answer no matter which group you choose, right? Also, this leaves too many holes in my theory. What if I had 2, 1, 3, 2, 4, 3, something like this. What's our best case? Is the answer to this just 2? We can't really move anything around. Yeah, we would have to have 2, 1, 3, 2. We gain 1 there. Well, no, it's 1, right? We gain 1, yeah. Answer would be 1. But if we flipped it, this was like 7, 7, 1, 3, 2. I do 7, 3, 2, or 743. Doesn't matter. 1, 3, 2. 7, 1. What if it was 7, 6, 5? 7, 6. Let's do 7, 6, 1. 7, 6. Okay. We would just take this and add it to a group, and then take this, add it to the other group. What if it was 3, 2, 7, 6, 1, 4, 3? We would do 3, 2, 1, 7, 6, 4, 3 and get 0. It's not so easy. So we should build. This is like a builder type question, right? I'm thinking we build array 1 by choosing the biggest element, 7. Then from that element, we ignore everything in front of it. We can't use any of those. Now, we take the next 6, then the next 4, then the next 3. Well, okay, this doesn't really work, because sometimes you want to sack the biggest element, right? If there's a longer chain somewhere. Do you? Do you ever want to sack the biggest element? So then we have 3, 2, 1, which is good. Here, if we start building, let's move this 1 to the front. Seven, 6, 4. Okay, well we said 7, 6. We can't take the first instance. So what if it was like this? If we take the first instance, we'd stop at 3, 2, 1. Well, what if it was like this? 7, 6, 3, 1. But it could be 7, 6, 4, 3, 1. Then we'd have 1, 3, 1, which is just 1. It is a DP problem. How can I do this problem? What's our DP state? So we're gonna need an empty array and start building, right? We should always start with our largest number and build from there. So, our best case. So we should build it backwards. I would like to think. Like if we have an array 176314113, 431. Sorry. We should say, what if our array was just 1? Then we would simply take 1, 0. If our array was 3, 1, we could do 3, 1, 0. If we do 4, 3, 1, 4, 3, 1, 0. 1, 4, 3, 1. One, 4, 3, 1. 3, 1, 4, 3, 1. 3, 1, 4, 3, 1. 6, 3, 1, 4, 3, 1. 6, 3, 1, 4, 3, 1. 7, 6, 3, 1, 4. This seems awfully convenient, doesn't it? Maybe this test case is just bad, because then you would do 7, 6, 3, 1, 4, 3, 1. I guess this is the crux, right? 1, 7, 6, 3, 1, 4, 3, 1. It's like, which one do you append it to? And since you can't, like, the answer to this one is always just 1, right? Okay. 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 8, 2, 3, 1, 1, 7, 4, 3, right? 7, 4, 3. 1, 1, 3, 2. We hit 2. We can't put it anywhere. So we put 2 in its own array. And then 8. Okay, I kind of understand how to build this now. So now it's, for this, it's like we put 1 in its own array. And then we have these here. Okay, I kind of understand. So for 1, 2, 3, 4, 5, we have 5, and then 4, and then we can't fit any of these. So these all go, like it goes in here, 2, 1, and then we just print the link to this. Okay. This makes a lot of sense. So for us to not have to iterate through the array backwards and like pop left and stuff like, or like insert left and stuff, we can just flip the array over, right? something like this, and then split 1, split 2, extra. For I in range start from 1 to n, split 1 should be equal to a 0. Check if ai greater than ai minus 1, or then split 1 the first element. We check the last element, right? Then split 1 dot append a why is this, isn't this supposed to be yellow? Not sure. It's supposed to be yellow, right? Oh, understand. Okay. I'll if so if this is not true, let's check if this is true. Wait, we need to check. If split 2, so if split 2 is empty, we just split 2 dot append ai, else if split 2 is not empty, we check this. If ai greater than split 2 negative 1, split 2 dot append ai, else extra dot append ai. Then we simply just print len extra. Alright. Next out of bounds. If split 2, if not split 2. Okay. 3, 2, 3. I'm getting 2 in this case. Why? Let's print split 1, split 2, extra. Let's isolate this case that's messing up. Seems like we reversed it fine. I think I understand. If AI is greater than or equal to okay. 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 We should test some of these other cases like this. 63143 Didn't put a single space because I am an idiot. And then expected is 1. Okay. Now, is there any test cases that would fuck us up? Maybe something like 611 211 should be 0. Oh. 112 should be 0. This seems like it works. Let's run it and see. Come on. Test 2. Okay. Yeah, it was too good to be true. Thirty-ninth case. Expected 1, found 2. Even 39 cases here. There are 39 times 2 is 78. Expected 1, found 2. One, 1, 2, 3. Could do straight up 1, 1 for 1, and then 2, 3 for 1, right? Or like 1, 1, 1, 2, 1, 1, 2, 3 also works. What does my thing do right now? Three, 2, 1, 1. Okay. Okay, I understand. The answer is simply there we go. Ooh, not good. I guess this is incorrect. So no bandage fix, I guess, for me. What is this doing? We reverse it, right? 3, 2, 1, 1. Now we have 3. Add that to something. Then we have 2. Add that to the other. We have 1, 1. It's valid. This one we have 3, 2, 1. We need to check if extra is valid. Is it a valid split, right? If extra is a valid split, then we can do this. If it's not, we simply just print len extra. So is there ever a case where extra is increasing? Well, we simply just check if extra is non-decreasing, right? If extra, sorted extra, bang. 3, 1. Okay. I wonder if this solves all our problems. I hope it does, but no promises. It's just not good enough. 372. Expected 2, found 3. It's Jover. But we have some edge case. Hmm. Mm. Well, I don't really DP at all, right? Like 3 groups should be good enough. 3 groups should. Like, I'm wondering if putting this here, if forcing this here, like block a placement or something, or like a better placement. Like maybe that's the extra. But then it's like, I don't know. Then I'm wondering if it's reversing that's breaking it, but logically it shouldn't matter. Hmm. Do we even need to build arrays? Can we just track largest value? Um, 8. So if we one pass it, we find 8. That's our largest value so far. So we store it. Find 2. We would track 8 and 2. Then we would track 3. 8 and 3, and next we'd have 1, which is less than both. Less than both. gotta be close. I just don't know how close. So what edge case am I missing? I think it has to do with extra. Suspected 2, found 3. Eight, 2. 3 is... So 3 would replace 8, so it'd be 3, 2, and then 1, 1, 2, and 1, 1. And then we have 7. 7 doesn't work, so we put 7 in. But we have 8, 3, 1, and 2, 1. Right now, 7 doesn't work. So we have 7. Okay. Well, for this case, yeah. One, 7, 6. So 1, 7, 6, 3. 1. then we increase 4, 3, 1. Okay, so now I'm thinking about this immediate force payment kind of method. Like, if, like, increasing, like, our penalty increases by 1, so as soon as we're not able to, we just increase the penalty. I'm wondering how this would work if there were multiple arrays. Like, okay, if we had this, we would track 2 arrays, 8, 2, right? So it'd be like, then we have 3, then we have 1, then we have 1, then we have 7, so didn't work for either of them. So let's pay the penalty for this. Our penalty is +1, and then we have 7, 4, 3, right? And then for this, 1, 7, 6, 3, 4, 3, 1, 1, 7, 6, 3, 1. Didn't work, so let's pay the penalty. 3, 1. This works, but now it's like, this is sheer greedy. Wonder if this works. I set it to infinity, right? Because it could be, we can't just set it to the first integer. First, it could be 1. Right, so let's set these to float inf, and then track a to print for I in A. So if we're gonna pay the penalty, we might as well replace the higher value or the lower value, right? So we have more room. So if A1 greater than A2, doesn't matter, greater than or equal to. If it's equal to, it doesn't really matter. Let's just reset A1 is equal to I. Else A2 is equal to I. This only happens if we need to, if x is less than, or if I is I is for index. Let's use x. Why am I using I? Stupid. Shit's so confusing. So if x is less than a1 and x is less than a2, we need to pay this penalty to check wait. No. If it's less than, it's good. If it's less than or equal to, it's good. So no, I was completely wrong here. It's like this. If a1 is greater than a2, then we should replace a1. Else we replace a2. Yeah, this is correct. Otherwise, if it's only greater than 1, so it's elif x is only greater than or equal to a1, then a1 equals x, and other way around, a2 equals x, else it's not greater than either, so we need to pay the penalty, so prime plus equals 1, and then we replace the smaller one if a1 is greater than a2, a1, a2 equals x, else a1 equals x. Print to print. I think this works for like the given test cases, but does it logically work? Not sure. Uh-oh. Expected 0. 1, 2. Right, this is expected 0 because yeah, this doesn't work. Fuck. Why didn't I think about this case before I implemented all my BS? One. What is this actually doing? One inf 1. We should check if a1 equal to x. Now we check okay, I think that fixes it. Yeah, this gives 3. This is correct. Oh my god. What is wrong? What is wrong? What test cases is fail on now? 17th. Okay, this is even worse. Actually, I don't want this. 1734. Expected 0 pound 1. 213. 213. So we take 2. We take 1. We have 3. Okay, so 213. We want to use up, like, if we can use, we should use, right? If we can use, we should use. If we can use, we should use? Is that true? 1, 7, 6. We're using greater right now, right? Are we telling it to use the lesser one? Just greedily fill up the lesser one? Like this? Like this would pass this case, right? I mean, I guess so. If we can use, we should use. I feel like that's not right. It is right, okay. I guess intuitively in my head, it made sense to just use the greater one, but I guess, yeah, that doesn't make sense. Using the greater one just gets rid of options. You should fill up the buckets you've already started first before you, yeah, because you could have like 6, then jump straight to 2, where like if you have a bucket of 6 and a bucket of 3, and your next insert is 2, if you put it in the bigger bucket, you have less room. Yeah, that makes sense. I don't know, what was I thinking? Okay, at least we got it. Took a few tries, but we got it. Oh, it was a bit harder, I will admit. Although, intuitively, this wasn't that hard. This wasn't even DP, really. This was just intuition. Like, I need to, like, spend a day or two to actually learn DP. Like, I understand the concept of DP, but it's just, like, so confusing to start. Like, this was tagged DP. I'm sure you can solve it with DP. I just don't really know how you would start it with DP. We can take a look at the tutorial. This one is C. Hint 1. Consider greedy. Yep, that's what I did. Solution 1. Consider the approach we start with empty, then assert elements one by one to the back. Our penalty depends on adjacent elements. So at any point in time, we only care about the yes. We now want to insert AI with the last element, especially use infinity. Yeah, that's what we did. Okay. Swapping the arrays BC does not matter, so without loss of generality, assume that I think this solution is exactly what we did, but what is this solution? Consider DP minimum penalty when we are considered Being splitting into two subarrays with the last element of one subarray's AI. The last is V. Speed up the transition by storing the state in a segment tree. Oh my god, math. I'm not even gonna look at this. Alright. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys next time. Bye.